5H, modulus functions. Modulus functions also can be called absolute value functions. So let's review absolute value symbol first. The absolute value of x, or modulus of x, is if x is a positive number or 0. The absolute value symbol has no use on this number, so we can remove the absolute value symbol. At this time, the absolute value of x is the same as x. If x is a negative number, when we want to remove the absolute value symbol, we need to make sure, okay, the number can become a positive number. So we need to add a negative sign to the negative number, make sure this number is positive. So you will see the absolute value of x is a piecewise function if we put a y in front. So right now, let's look at two different types of modulus functions in comparison with the original function y equals f of x. We have two different ways to add the absolute value symbols on. One way is to add the absolute value for x. The other way is to put the absolute value symbol for f of x, which is the same as y. Based on this one, if we put the absolute value symbol on x, we find that f of the absolute value of negative x, because the absolute value can change any numbers to be positive numbers or 0. So this one is the same as the absolute value of x. So which means y equals f of negative x is the same as f of x. So this one will give you an even function, which means the graph of this function should be symmetrical about the y-axis. But for this absolute value function, where we add the absolute value symbol on y, there's no even and odd property on this one. So since the first one is an even function, and we will realize, okay, the graph should be symmetrical about the y-axis. That means we can discard the graph for x is less than 0. So the part for x is less than 0 should be symmetrical with the other side on the positive part. Refracted over y-axis, since it's an even function. Points on the y-axis are invariant because the y-axis is the axis of symmetry. Let's look at this one, the second type. If we put an absolute value on y, that means no negative y values anymore. So we keep the graph for y, or f of x is larger than or equal to 0. The graph should be refracted over the x-axis for f of x equals smaller than 0 part. And the points on the x-axis are invariant. That means you do not change those points on the axis of symmetry. So let's follow those conclusions to graph. The original function is f of x equals 3x times brackets x minus 2. So we need to graph these two different types of modulus functions. No matter which one you want to graph first, we need to graph the original function. Let's look at how can we graph this original function. Most of you guys realize this one is a codrive function. You will see two x-intercepts. One is x equals 0. The other one is x equals 2 if we let y be 0. So 0 and the 2. There are two x-intercepts. So I will know the axis of symmetry for this parabola is x equals 1. So when x equals 1, I sub 1 in for x, So we can get y value is 3 times 1 times 1 minus 2, which is -3. So 1, -3 is the vertex. So if you want to graph this original function a little bit more accurate, you can pick up more value, for example, x equals 3 in. So when x equals 3, you sub 3 in for x, this value will be 9. And at the other side, you have another one, which is x equals -1. The y value is 9. So this is the parabola we can graph for the original function. Okay, so right now we want to graph the first type of modulus function, where we add the absolute value on x. Follow the conclusions we did. So we need to discard the graph for x is less than 0 part. So for this part, x is less than 0, this is x is less than 0 part. I will erase this part. Then look at the second point. Refract the graph over y-axis. So I refract this one over y-axis. So 0, 0, because this one is on the y-axis. So this is the invariant point. So refract this vertex over the y-axis. This one become -1, -3. And this point become -2, 0. This point will become -3, 9. So if we add the absolute value symbol onto the x, this graph look like this one. Okay, it looks like in the W shape, but with 2 ends growing forever. Let's look at how can we graph y equals the absolute value of f of x this time. So the same idea, I still need to graph the original one. So we can graph the original one very quickly right now by using those points. This time you will see the absolute value is on y. So that means on the original function, all the y values become positive values. So you will see these two parts are above x-axis. That means all the y values on these two blue parts are positive. So you can keep them. Then for this part, it's below x-axis. That means all the y coordinates on this part is negative. So if they are negative with the absolute value, they become positive. So what I will do is I refract this bottom part over the x-axis. So this 1, -3, the vertex becomes 1, 3. I flip this bottom over x-axis. So the blue graph is for y equals the absolute value of f of x. So we call this one is a McDonald's symbol, but it's a kind of upside down McDonald's symbol. Okay, right now, let's look at more practice questions. So this is a question in your guys' textbook as well. I have 3 different original functions given by the graphs. So we need to graph the first one, where we add the absolute value on y. If you add the absolute value on y, that means you keep the graph above the x-axis. For example, the first one. You keep the part above the x-axis and flip the part below the x-axis over the x-axis. So this 0, -2 becomes 0, 2. So the blue one is y equals the absolute value of f of x. The second one is the same. Let's change all the negative y values to the positive y values. So you will see this is a positive y, keep it. This is negative y refracted over the x-axis. And this part is above the x-axis. Keep it. And this part is below. You flip this part. Over the x-axis. So this blue one is y equals the absolute value of f of x. The same to the last graph. So this one is above. I will keep it for the absolute value of f of x. This part is above. I will keep it. 0 is on the axis of symmetry, which is the x-axis. Keep this one. So flip this bottom graph over the x-axis. So the blue graph is for y equals the absolute value of f of x. Okay, the second question is, repeat a, but this time graph y equals f of x and y equals f of the absolute value of x on the same set of x-axis. So for this type of the absolute value function, I will use the red one. So if you add the absolute value on x, that means you keep up the graph for x is larger than 0 part. So you keep this part. Then you refract this part, the red part, over the y-axis. So this one, 2, 0 become negative 2, 0. Okay, so the red one is for y equals f of modulus x. Let's look at the second one. The second one is the same. I will keep the graph for x is larger than 0 part, including this 0 point, which is on the y-axis. So this point, even if refract over the y-axis, this point is still on the y-axis. So the other part is you refract the red graph over the y-axis. So 2, 0 become negative 2, 0. So refract over. The red one is y equals f of the absolute value of x. Okay, this one is the same. Let's keep all the graph for x is larger than 0. I refract the red graph over the y-axis. And this time you have a vertical asymptote, which is x equals 4. That means on the other side, you will have x equals negative 4 as the vertical asymptote. So I reflect this part over the y-axis first. Then reflect this part over the y-axis, which is here. So if you can find some critical points, always use the critical points to help you to graph this part more accurately. But if you are not able to find any critical points, you just use your observation skill to make sure, okay, they look symmetrical. So here is the whole lesson. This is the homework.